So welcome back, everybody. It's 11:10, so we'll start again. I'm Richard Emsley from King's College London, and I'm chairing this next session, which is on documenting estimands and aligning the analyses. So I know a number of the questions we've had so far have been about how we actually estimate some of these estimands. That's going to come in the second talk from Ian White. But first, I'm going to hand back to Susie Crowe, who we've all met through the workshop, who's Head of Trials Methodology at Imperial Clinical Trials Unit, who's going to talk to us about how to document estimands, first of all. Thanks, Susie.
Thanks, Richard. So I'm going to talk about now documenting estimands in the trial protocol, the statistical analysis plan, and in trial reporting. And I'll also touch on documenting changes to estimands. So I think let's first start with what the ICH E9R1 guidelines say about defining estimands in trial protocols. Well, it specifically states that a trial protocol should define and specify explicitly a primary estimand that corresponds to the primary trial objective, and how the protocol and the analysis plan should pre-specify the main estimator that is aligned with the primary estimand and that leads to the primary analysis. So together with a suitable sensitivity analysis to explore the robustness and the deviations from its assumptions. So it's quite clear that the protocol should include both the primary estimand definition and the methods of statistical analysis that align with this. Those methods that will be used to produce an estimate of the estimand. So along with methods of statistical analysis that will be used for sensitivity analysis of the primary estimand. So what about estimands for secondary trial objectives? So the guidelines state that estimands for secondary trial objectives, for example, those related to secondary variables that are likely to support regulatory decisions, should also be defined and specified explicitly, each with a corresponding main estimator and a suitable sensitivity analysis. Now, in many of the trials that are conducted outside of industry, so in our academic trials units, we won't necessarily have secondary objectives that will support regulatory decisions, but we will have secondary trial objectives that will support key decisions made by other stakeholders that we could interpret we should be including estimands for. But I think what constitutes as key is at the discretion of investigators who can make sensible and pragmatic decisions. Now, obviously, all the benefits of specifying estimands for the primary trial outcome, so that's for clear and transparent interpretation and ensuring the question of interest is actually addressed, they also apply for the secondary outcomes. So it's beneficial to specify estimands for all secondary objectives. But the guideline, as we see here, is open to interpretation on this matter. Now, looking beyond secondary objectives and at exploratory and tertiary objectives, the addendum states that additional exploratory trial objectives may be considered for exploratory purposes, leading to additional estimands. So while it's beneficial to have clarity on what's being estimated, it's not a requirement to document an estimand for every exploratory objective. So again, this is up to trialists to make sensible decisions as to what to include. So where in the protocol should estimands go? Well, the ICH addendum isn't prescriptive on where in the protocol that the estimand should go, nor how they should be described. So trialists are free to insert these in the way they see fit. Now, along the few trials that I've seen, including estimands in their protocols, I have actually seen quite a bit of variability. So as Chrissy was discussing yesterday, we see some trials put their estimands immediately after objectives and outcomes, whilst others only describe them in their statistical analysis section. So there isn't a right or a wrong way to include estimands, like being there's the most important. But one nice template for how estimands can be included, that was one that Chrissy mentioned yesterday, is the Transcelerate protocol template, which I think is very nice. So I'm going to show you this now. So it's how we at ICTU are approaching including estimands in our trials. So Transcelerate itself is a consortium of industry partners, and their templates freely available at the web address on screen. But here, the main description of the estimands come early on following the objectives and the endpoints. Then in the statistical methods section, analysis methods that align with the estimands are described. Now, as estimands are not just a statistical matter, they clarify exactly what question the trial is going to address. I think this way of including estimands is quite appealing. But the Transcelerate protocol template does also suggest including a high-level description of the estimand in the initial synopsis. Now, with regards to how to specify the estimand, the template recommends listing the objectives and your endpoints. So that's just standard. But then the definition of the estimand follows this. So they then give some example text that can be used and edited as required for how the primary estimand can be stated, which I've just copied here to show you. So this consists of an overall description of the question. So that's the estimand that's being addressed, followed by a description of each of the 5 attributes using bullet points. So they also suggest including the rationale for the chosen estimand underneath. So here's an example of how this can be used for the primary eczema trial that we considered designing yesterday. So here, the primary estimand overall description is what is the mean difference in the change from baseline in EASY at week 12 in patients with severe chronic eczema, as defined by the trial inclusion and exclusion criteria, treated with the biologic compared to placebo at 150 milligrams every other week, regardless of discontinuation of investigational intervention for any reason or initiation of rescue medication or topical therapy. And then, as you can see here, the template suggests using bullet points for listing the 5 attributes underneath. But I've also seen nice examples where the estimand is displayed in a table with the description of the estimand in the top row and a subsequent row for each estimand, like we saw for the COVID vaccine trial yesterday in the surgical trial. Now, the same templates provided for writing secondary estimands. So that includes giving a summary of the estimand, followed by a list of the 5 estimand attributes. Now, of course, other standard sections of the protocol documenting key design and conduct and analysis matters will want to reflect and align with the choice of the primary estimand. It's worth pointing out that the current reporting guidelines for trial protocols to the spirit statement don't include estimands just yet, but these were published before the publication of the ICH-E9, so it will be interesting to keep an eye on this in future years. Now, the protocol is not the only place to document estimands. So the addendum indicates that the protocol and the analysis plan should pre-specify the main estimator that's aligned with the primary estimand and that leads to the primary analysis. So this with a suitable sensitivity analysis. So the statistical analysis plan is a trial document which usually houses the full details of the plan's statistical analysis. So it's important that the statistical methods outlined in the SAP also acknowledge and align with the estimand. Now, the current really brilliant guidelines for the contents of SAPs that were published in 2017 by Gamble et al. Don't include estimands in their content list, but these guidelines were published pre-ICH-E9 R1. And it's notable that even at that time point within the publication, they stated how key initiatives that may influence the SAP content include the addendum to ICH-E9 on estimands and sensitivity analyses. More recently, an early phase clinical trials extension to the guidelines for the contents of SAPs was published just earlier this year. This was by Homer, Gaunt, and others, also including Gamble. And these do include specifying estimand descriptions within the SAP. So their content list includes listing and describing each primary and secondary estimand, including detail of each attribute. So this extension suggests it's likely that we may expect estimands filtering through to the main SAP guidance soon upon updating. So that's documenting at the design stage. So at the other end of the trial journey, when the trial completes, to avoid misinterpretations and understand exactly what a trial is estimated, estimands should be clearly reported in the trial report. So this will enable all stakeholders to make informed decisions around medical interventions in policy and medical practice. But as you heard from me yesterday, this isn't yet current practice. So we saw yesterday that no trials published in 2020 in the 6 leading general medical journals presented a full description of the estimand in their publication or their supplementary information. Now, 4 trials attempted this, but missed 1 or more of the 5 estimand attributes, making it not clear what question the trial has addressed. So there's clearly a long way to go to ensure there's no misinterpretation of trial results. There's no doubt that it will be challenging to get estimands into published trial reports due to restricted word counts. As you heard from me yesterday, I could only get the estimand for 1 trial into the supplementary appendix recently and the word treatment policy in the main article. I think once more people understand the importance of the estimand for improving trial interpretation, I hope it will get easier. But we can make use of our supplementary appendices until then and make sure we reference the estimand location in the main text to make sure it's accessible. As we did have some discussion around yesterday, the consult guidelines for trial reporting don't currently include estimands, but again, these were published a while ago now. And as we heard, these are due to be updated soon. It's notable that a recent extension to Consort, the Adaptive Design Extension Statement, does acknowledge the Estimand framework in its publication. So I think we should watch this space regarding Consort. I really would like to see Estimands come into Consort reporting guidelines. But on reporting, I just flagged this study that I came across from 2021 in NEJM. So this partially included Estimands, where in fact Estimands made it into the abstract as well as the main text, which was great to see. So this included a top-line overview, and then they referenced a supplementary appendix for more details. Now, unfortunately, the population and the population level summary measure wasn't explicitly stated as part of their Estimand definition. So this aspect needed inferring. But this is partway there and shows us how there's some initial filtering through of Estimands that's begun. But the last thing that relates to documenting is on changes to the Estimand. Now, naturally, at the outset of the trial, it might not be possible to foresee all intercurrent events. So unplanned intercurrent events might occur, which can impact the Estimand. For example, recently the COVID pandemic brought with it some new intercurrent events in some trial contexts, such as disruptions to standard of care. So the ICH-E9 addendum acknowledges that a change in the Estimand can occur, and this would usually require a protocol amendment. Now, where it's not possible to amend the protocol, it states how in reporting, it should be explained how the unforeseen intercurrent events or changes were handled in the data analysis and interpretation, and the impact on what the revised analysis estimates were versus the pre-specified Estimand should be kind of explored. Being transparent really is the key factor that's highlighted in the addendum. Now, just whilst we're on unplanned events, if you are currently involved in a trial that's been impacted by COVID, I just wanted to draw your attention to a preprint that's under review at the moment, which discusses Estimands and their estimators for clinical trials impacted by COVID. So within this context, we discuss hypothetical and treatment policy approaches for handling the impacts of the pandemic. We also have a paper in BMC Medical Research Methodology that presents a 4-step strategy for handling missing outcome data in trials that have been affected by a pandemic. But to summarise, with regards to documentation, so we see that the protocol should include the primary Estimand definition that corresponds to the primary trial objective, and the main estimator that aligns with this, and sensitivity estimators. Estimands for secondary trial objectives used for regulatory or other key decisions with corresponding estimators should be included. We've seen the Transcelerate template, which provides a useful protocol template. And also the analysis plan, be this in a protocol or SAP, should include full details of the aligning estimators. Estimands in final trial reports will ensure no room for misinterpretation, but I think we've got a long way to go on that there. Brilliant. So that brings me to the end of the slides. So I'll hand back to Richard.
Thanks very much, Susie. A couple of questions have come in that I think may be worth us addressing now. And sorry, I've lost your screen there. So the first one is from Laura, which Ian's partially answered, but we seem to get your take. Would you say that specification of analysis populations such as ITT and per protocol are now superseded by the Estimands framework when we write that in the protocol or the SAP? Because I noticed in your template, it still had a section, I think 9.2 for analysis populations.
Yeah, see, that question makes me want to find a dictionary and look at what supersede actually means. Because I think like Estimands aren't going to be replacing these. I think it's important to have our Estimand and our analysis methods. I think the Estimand's just adding to it and clarifying what's the purpose of that analysis population. It allows us to judge that we've got the right analysis population. So I don't right now. The definition of supersede escapes me, but I think they'll both be useful.
Question from Wu: when there are several, say more than 5 secondary endpoints, should we define Estimands for each of the secondary endpoints and include those in the protocol?
So good question, and I think based on the guidelines are quite sort of grey in this area, as in basically you can make a sensible decision as to whether you want to or not. Personally, I have put recently I have put Estimands for all secondary outcomes in. Obviously, that's because I love Estimands and wanted to go in and can really see the benefits of Estimands. But I guess it depends on your resources and time. So yeah, you can make sensible, pragmatic decisions here. There's no requirement to have estimands for every secondary objective, but obviously all the benefits of having estimands really do help, and they make sure that you can know that you're answering the right question for your secondaries as well as your primary.
One final one before we move on, which I guess is a concern that many of us would have on the call, is does implementing the Estimand framework in trials increase the workload for the trial statistician? How have you found that in your experience?
Yeah, so it's a good question. I guess, I suppose thinking about the forwards trial earlier, when we were going through that, it sort of felt like this was newness. This is additional time that I'm spending explaining estimands to the team and then going through the questions. But what I actually think is that was time that maybe would be spent later down the line, but it's just now shifted so that actually we're really clear up front on what we're doing. So maybe it's just a redistribution of time, because at the end of the day, estimands aren't really entirely new. We've already had a target behind all our analyses. But obviously right now is a little bit of extra time because we need to educate our clinicians and talk to them and make sure everyone understands what's going on. And also whilst we get familiar with them. So there's the learning going on as well.
Okay, thank you. It's time to give you a break, and we're going to move to our next presentation, which is from Ian White. So many of you will know Ian. He's Professor of Statistical Methods for Medicine at the MRC Clinical Trials Unit at UCL. And he's going to take us through aligning the analysis with the Estimand. So over to you, Ian.
Thank you, Richard. And can you see my screen?
Yes, we can. Thanks.
Fantastic. Okay, thank you. So thank you for the introduction. And I'm really enjoying this workshop. And I think it's great that we spent most of the rest of these 2 days talking very much about what the Estimand should be and defining it. And we're only spending this fairly brief period on actually how we do the analysis, because really the Estimand should be the driver and the analysis should sort of follow on. Of course, there may be situations where we find we've written down an Estimand that we can't reasonably or comfortably analyse, estimate, in which case perhaps we should go back and have another think about our Estimand. But usually the flow is very much from you choose your Estimand and then you choose your analysis. So I'm going to focus very much on the intercurrent event attribute of the Estimand. But before I do that, I'm just going to point out that the population level summary attribute of the Estimand is also very important. I really like the fact that Estimands don't have to be parameters in statistical models. So we might have an Estimand which is a marginal mean difference or a risk difference, which is really easily interpreted, a lot more easily interpreted than some parameters in some of our statistical models. But we can still use complex estimation, like a covariate adjusted regression model, which we would want to do to gain power by adjusting for covariates, and then add in an extra step after fitting a model to compute our Estimand from the results of that model. And Susie's already cited Tim Morris's very nice paper, which talks more about that. So now back to intercurrent events. And this list is by now, I think, very familiar. That's just my recap of the 5 strategies. And basically this talk is going to go through those one by one and talk about how we may tackle our analysis for each of those Estimands, finishing with a section on hybrids. And mostly I'm going to be talking about treatment policy and hypothetical strategies for reasons which I think will become clear. So let's start with treatment policy strategy. And for the most of this talk, for simplicity, I'm going to imagine we have just a single intercurrent event and talk about the handling of that. As I say, I will come back to hybrids towards the end. So if you have complete outcome data, then estimation for treatment policy strategy is really very easy. You just analyze the observed data, and that's that. The whole meaning of treatment policy strategy is that that outcome is meaningful. Whatever intercurrent event has happened, the outcome is meaningful, so you analyze it. So if you have complete outcome data, that's fine, we're done. Of course, in practice, you don't. You're going to have incomplete outcome data. But then you might say, well, okay, but we have standard ways to handle missing data. And I'm thinking of incomplete data as both missing data on binary or quantitative outcomes, but also censoring of time to event data. Those are both forms for me of missing data. So we have standard ways to handle that. Do we have a problem? Well, maybe not, but in some cases we do. So the next few slides are going to focus very much on the case where we have an intercurrent event like treatment discontinuation, which makes missing data more likely. People who stop their treatment are also more likely, I think, to stop their follow-up. And it makes outcomes worse, because if treatment's beneficial, then discontinuing it means you cease to get that benefit. And so what that means is that our standard ways may not be reasonable, because our standard approaches to missing data and censoring assume that data are missing at random. And that's unlikely to be true unless we take our treatment discontinuation into account. And I've got a picture that hopefully makes that very clear in a minute. So I'm going to go through two flavors of this problem. One where we have no data on the outcome at all after treatment discontinuation, and then one where we have some data after treatment discontinuation. And the latter is much to be preferred. We should design our trials to do that. And I've just put a link there to a very nice project called Persevere, which talks about how to work with trial staff and patients to unlink stopping treatment from stopping participation in the study follow-up. Okay, so here's a picture that sets out basically what the problem is. So we've got some orange-faced people, the smiley face denotes they are on treatment, and some unhappy green-faced people who are off treatment. And this is the situation where all the green faces, all the off-treatment people have missing data. And there may also be some missing data amongst the on-treatment people. And then the problem here is that if we assume missing at random in our analysis, which is what our standard approaches to handling missing data do, then we would be assuming that these missing values are comparable to these observed values, possibly after accounting for other covariates that may differ. And of course, that's a problem, because then we would be imputing or otherwise inferring these missing values based entirely on on-treatment values. So we'll be sort of imputing on-treatment values here. And in fact, that means that what we'd be doing is we'd be estimating a hypothetical estimand. So we'll park that thought for now, but we'll come back to it when we talk about hypothetical estimand, because this is going to suggest ways in which we would estimate hypothetical estimands. But sticking with the treatment policy estimand for now, this means we've got to find a missing not at random procedure for doing this imputation. And I'm going to talk for a little bit about reference-based imputation, which is an idea that identifies a reference group whose outcomes may inform the outcomes of off-treatment patients. So this is usually the control or placebo group in a study. And it constructs the distribution of the missing data from which we're going to do the imputation by combining information on fully observed individuals in that treatment group with some information from the reference group. And the next few slides should make that a lot clearer. So I won't go through this in detail, but this is the scheme from a paper by James Carpenter, which introduced this idea. And I'm going to go through these pictorially and using slides, which I think I may have nicked from Susie at some point, in which case, thank you, Susie. So to begin with, what you do is you analyze the observed data. So remember, we're considering the situation where all the data are on treatment data. So this is basically an analysis for a hypothetical estimand. We would fit a multivariate normal distribution to the placebo and the active arm. So maybe those would be the means that we come up with. And then we go on to form a distribution. We're not going to use that to impute the data. We're going to form a joint distribution of pre and post discontinuation data. And we're going to do this for each patient who discontinued treatment. So for this slide, we're going to just consider a patient who discontinued their trial treatment after the 6th-month visit. If we made a missing at random analysis, we would assume that this red line for active remained relevant going into the future, and we would impute values around that. but we've just seen why that's not the right thing to do. And there are several flavors. Jump to reference would say that we create that red dashed line, that mean profile for this patient who discontinues after 6 months, by following active up to when they discontinue, and then jumping and following the reference mean out here. And we'll see how this is implemented in a minute. Copy reference says we simply assume that they follow the placebo, the reference trajectory, even in the past as well as in the future. And copy increments in reference says that they follow their treatment group profile in the past, and then they continue parallel to the placebo group. So this is especially relevant in a situation as here, where the treatment effect seems to be increasing over time. So then that sets us ready to actually impute the post-discontinuation data. I'm going to take copy increments of reference in reference as an example, just to show you how it works. So we're hoping to impute using this red dotted line as an individual mean profile. But we're not going to just impute on that line, because this is an individual who will have some observed values before their treatment discontinuation. This particular person has values above, meaning slightly worse than the means. So their residuals are positive. So that means we would expect the values that we impute to also lie a bit above the mean. And so these little purple normal distributions here are suggestions from a distribution from which we might impute the values at 9 and 12 months. And then we repeat this for each patient, and then we repeat it m times to get m imputed data sets, and we analyze them using the standard approach Rubin's rules for multiply imputed data. So what have we done here? We've made some assumptions, and these turn out to correspond to assumptions about how treatment works after it's discontinued. So jump to reference says that treatment has no effect at all after it's discontinued. Copy increments in reference says that the treatment has a maintained effect, but not increasing. And copy reference sits somewhere in between. So the data don't tell you how to do these. You have to decide which of these is the right thing to do from your understanding of the treatment and how it may continue to affect people after it stops being taken. I've listed various bits of software there. Susie wrote a data package called Mimics, and we've been working recently on something for R, although there's another rather nice package that's come out as well in R. And James Rogers' 5 macros did this in the first place in SAS. I've just gone the wrong way, sorry. There we go. Okay, now let's turn to the second case where we have some data after treatment discontinuation. So what we've got now is we've got one of these green faces over here. So we've got at least one person who's off treatment, but is still being observed. So that's still a problem, because if we make a missing at random assumption, we're imputing these missing values over here on the basis that they're comparable with these observed values, again, possibly conditional on some covariates. And that means that these people who are only 1/6 treated are going to be imputed as if they're 5/6 treated. So that's not going to work either. We're going to have to fix this by assuming a missing at random assumption conditional on treatment. In other words, these 5 green people over here are going to have to be imputed to be like just this green person over here. We're going to have to stratify in some way. And we're going to implement this by multiple imputation. And this is very much work in progress, I think. I've got some work ongoing with Tom Drury at GSK, where we're imputing sequentially, meaning we're imputing each time point in turn, and we're allowing whether people are on or off treatment at each time to affect their mean outcome in that imputation model. So that allows for systematic differences in outcomes between people on and off. And then optionally, we make the models more complicated. We allow on-off treatment to affect the slope on previous outcomes, and maybe not just on-off, but the time when a treatment was previously stopped. And we've implemented this in SAS-Proc MI, but it ought to work in other software too. There are also macros by James Roger. That's a website with a lot of resources, and there is quite a lot of other work ongoing in this. So I think the idea that we need to take a account of on-off treatment status imputation is the key one here. So my summary for treatment policy estimand would be, if you've got complete data, you are fine. The analysis is very simple. If you've got incomplete data, but you think the data being incomplete isn't related to the intercurrent event, then you're also fine. You can do a standard missing data analysis, might be a mixed model, might be a multiple imputation. If, however, the risk of having missing data is related to the intercurrent event, then you're going to need to use either a reference-based imputation for the situation where you have no data after the intercurrent event, or some form of MI, I think, for the situation where you do have some data after the intercurrent event. So that's it for treatment policy. I'm now going to talk very briefly about the composite strategy. This is very easy, so I really don't need to say very much, because if you're handling your intercurrent events by a composite estimand, that means you simply bundle it in to your outcome statement, and there you are. Estimation is extremely straightforward because your outcome's observed. The issue with the composite strategy is that it may lack clinical meaningfulness rather than that it's difficult to estimate. You sort of trade-offs there. And I would just note that when we have composite outcomes with some missing components, that can be tricky. So if that's your situation, we've got a nice paper in Stats and Medicine last year. So let's move on to the hypothetical strategy. And people who've spoken previously today have talked about one approach, and I do want to mention the second one. So the basic idea would be that you can exclude the data that are observed after the intercurrent event. Of course, there may not be any, but if there are data, it's been said previously, well, they're not relevant to this, so you would exclude them or not even collect them in the first place. And then the idea of analysis, and I'm going to go through this in a few more slides, the analysis would try to recreate the data that would have been observed hypothetically if the intercurrent event had not occurred. And we're going to talk about a multiple imputation, mixed model, and something called IPCW, which I'll explain in a minute. But we have to recognize that this potentially causes selection bias, because by excluding data, all of those approaches that fill in what we would have observed hypothetically are going to have to make some assumption about comparability of the people who have the intercurrent event and those who don't, conditional on baseline or time-varying covariates. So we're going to need to adjust for these covariates, and that's going to tend to point us towards the multiple imputation or an IPCW approach with an assumption of no unmeasured confounders. I think it's an interesting point, which I'm just going to make and pass on from, which is that selection bias of this nature does also arise in reference-based imputation, but it generally gets ignored there, possibly because there are enough decisions that are difficult anyway in reference-based imputation without having to worry about this one too. But in principle, I think we should worry about it. However, there is a second analytical approach, which is that we can use data that are observed after the intercurrent event. And if you think about it, they must have some relevance. If all the data that occur after an intercurrent event are extremely bad, that must be telling you something about the sort of people who are having that intercurrent event. So just to exclude might be missing something. So there is a second approach which models the effect of the intercurrent event. And again, I will talk about that a bit more. But basically the idea is to work back to what would have been observed without it. Okay, so let's first of all focus on this exclude idea. And for example, I'm going to talk about multiple imputation. So the problem we're talking about here is, what we talked about earlier was, do you remember I said how if we weren't careful, we were going to be doing a hypothetical estimand. Well, now this is where we're going to harness that, because if we do a model like a mixed model or multiple imputation, where we take little account of the fact that the intercurrent event has occurred, then we're going to be imputing our values as if they were still on treatment or without the intercurrent event. And so this suggests that we can do a multiple imputation approach, or we can do a mixed model approach, which of course doesn't actually impute, but implicitly it does impute. You may be less aware of IPCW, which is a neat alternative that I want to just spend a couple of slides describing. IPCW stands for inverse probability of censoring weighting, and it's a misnomer because actually we weight by the inverse probability of people not being censored. We can handle multiple intercurrent events, but the idea is that we censor, we exclude data after it. Then we model the time to the intercurrent event, and crucially here we can use time-updated covariates, so we can allow for time-varying confounders. We compute the probability of remaining uncensored and use the inverse of that as time-dependent weights in the analysis. And this really applies very generally, whatever your primary analysis is, whether it's analysis of continuous or survival data or whatever. And there's a design implication here. We've talked a little bit about this. We can record, we need to record all the time-updated covariates that are prognostic and predict switching. And this may introduce more burden into our trial procedures. So here's a picture that summarizes how IPCW works. It's going to work within one trial arm. Here are 7 people who are the participants of that trial arm. The colors here don't correspond to the colors in the previous slides. They just mean different values of some covariate. These people are all going to have weight 1 to begin with. We're going to follow them over time. And after a little bit of time, maybe that person down there has an intercurrent event. So we're not going to use their follow-up data thereafter. But the good news, there are 3 other people who are comparable with that person. So this is the no unmeasured confounders assumption we're making. We're going to assume that those other 3 people can happily be used to represent what that 4th person would have had they not had the intercurrent event. So we weight them up with a weight of 4/3. And you can understand that as either 3 people meant to represent 4, or it's the inverse of 3/4, which is the probability of not having the intercurrent event. Let's follow people up from a bit longer. Some of these covariates turn out to be time-varying covariates. And let's suppose that person there now has an intercurrent event. Well, we can still identify a comparable person. So we're going to give them a weight 2 to compensate for this person who we're not now going to follow up. And those weights get multiplied together. So all's going very nicely. I'm also going to illustrate on this picture the problem that can arise with IPCW, which is if, say, that person now has an intercurrent event, we have nobody that they are comparable with. So we cannot use IPCW to weight somebody else up to represent what they would have had. And this is sometimes called the positivity assumption. There has to be a positive probability estimated that each type of person can proceed without an intercurrent event. And that's not true for people with orange faces in this picture. So this just tries to describe the same things in words. I've mentioned here the no unmeasured confounders assumption, the positivity. Instrumental variables estimation avoids both of those. So it makes a different assumption. I'm going to be quite brief about this. Instrumental variables is an idea originally from econometrics, which makes the different assumption that the treatment effect is in common whether you get treatment through being randomized or through switching to treatment. And primarily this approach is most appropriate for non-adherence or for switching to treatment of another trial arm. And very roughly, the idea is that we have a model that relates the observed outcomes to the potential untreated outcomes. They must balance across randomized groups. And so we find a model parameter that achieves that balance. So for quantitative outcomes, the standard econometric models are valid. So for example, in Stata, there's IV-Reg. For survival data, I'm going to illustrate a technique with a mouthful of a name, the RPS-FTM. So this is from a trial of a drug in cancer, in a particular type of cancer. Patients in the placebo arm were able to start the drug sunitinib on disease progression. And in fact, this happened quite a lot over time, not in the very early bit. And you can see the impact of that on this intention to treat analysis, because the difference between sunitinib and placebo is initially large, but as the treatment switching builds up, the curves come together. And we might be interested in a hypothetical Estimand, because this switching wouldn't occur if the drug weren't approved. We will either have sunitinib given to all patients, or simply it will not be available at all. And the RPS-FGM allows us to estimate this purple curve, which is what, according to the model, would have been observed in the placebo group had switching not occurred. And this gives a much more impressive hazard ratio of 0.5, although the same p-value. This approach doesn't give any new evidence for treatment effect, but it gives a stronger and wider confidence interval. Okay, so I'm just coming on to the last two strategies now, the principal stratum strategy. Well, I don't think this is particularly easy in general. I was interested to hear that Susie wanted to be trying to estimate principal stratum in the trial she spoke about earlier. I'm just going to flag a couple of particular cases where we can do this. So let's consider the intercurrent event of not starting treatment at all. In a double-blind trial, the subgroup of participants who don't start treatment have got to be comparable across treatment groups. So therefore, people who will start treatment is a valid principal stratum, and we can simply do an analysis, you might call it modified ITT, of participants who don't start treatment, and that is going to be estimating the treatment effect in that principal stratum. And Brennan's got some work in progress on that. In some other trials where you have all or nothing compliance, and I think it's crucial that this technique is best suited to all or nothing compliance. Think, for example, a surgical trial where you either get the surgery or you don't. We can estimate something called the complier average causal effect. And there's a reference to a nice applied description of how to do that by Graham Dunn there. And computational approaches, well, yeah, they're there. It's not the most straightforward, but there are things there. And then the last strategy is the while on treatment strategy. And I'm going to focus on the case where we have data that are missing or truncated due to deaths. And I've been thinking about this in particular in trials in palliative care, where we're not trying to extend life, we're trying to improve quality of life or reduce symptoms. And I think this while on treatment strategy really makes sense here. Treatment policy really doesn't. And another term for the while on treatment strategy is the partly conditional Estimand. There's a very nice reference, Kurland, there, if you're interested in this topic. I think if the analysis is very straightforward, if we're interested in a single time point, we simply compare the two treatment groups restricted to those alive. And we have to recognize these are not strictly comparable groups. It may be a sensible thing to do, but the nightmare concern in this setting is that we might have a treatment that shortens the life of the people who have the worst quality of life. And that would cause this comparison to show a benefit to treatment because of comparing not strictly comparable groups. At the very least, we need to set this analysis alongside a comparison of survival. If you have multiple time points, you've got to tailor your analysis techniques quite carefully to avoid implicitly imputing data after death. You could do an analysis time by time, like I just described. If you really need an overall analysis, you have to look at doing a generalized estimating equation with an independence working correlation. It's that independence that ensures that you don't impute after death. This slide describes a possible hybrid strategy. If you have various intercurrent events for which you want to use treatment policy, the composite, and the hypothetical strategy, so I'm going to call them included, component, and excluded events, then I think you can put it all together in a way something like this. Well, the composite bit's easy. You simply form the composite and then carry on. Then you're going to have to censor at the excluded event. So I'm not really talking about the modeling approach, I'm talking about the excluding approach. Don't censor at the included events, only the excluded events. And then multiply impute the missing data. As we've said, they're going to be in particular after included events. So you're going to have to take account of these included events, just like you did in the first part of this talk. We'll include the event status in the imputation model. If necessary, use a reference-based imputation, but don't impute missing data after the excluded events. Or if it's computationally easier, do impute them, but then delete them again afterwards. And then you can handle the missing data after the excluded events by multiple imputation or by IPCW. And interestingly, you don't want to take account of any of the events here. There's a slight problem that, no, I won't say that. That's okay. So let me conclude. I think all of these estimands, in general, we can have a good go at estimating them. Principal stratum estimand perhaps should only be tackled in settings with simple intercurrent events. The treatment policy and the hypothetical estimand usually require untestable assumptions around missing data or around comparability of people with and without intercurrent events or around a common treatment effect. People are often a bit uncomfortable about making untestable assumptions, but often I think it's something that we simply have to do. The ICH E9 main message still applies, I think, that we should clearly state the estimand and we should clearly state the assumptions we need to estimate it. And I've only sketched some of the approaches. I haven't been exhaustive here. I hope that was helpful and I look forward to hearing your questions.
Thank you very much, Ian. That was a fantastic overview of all of this. There are no questions in the chat at the moment, so people can raise their hands if they would like to ask a question directly. I mean, one of the things, the links to the previous discussion, I think, is there is a degree of complexity to some of this that is beyond what many of us have been doing in our trials thus far. You know, I was moaning the other day that I don't want to spend the rest of my career fitting linear mixed models. And I think if we embrace this framework, I'm probably not going to be doing that. So what are the kind of the best ways of upskilling our clinical trials community in these methods, which we're going to need if the Estimand framework takes off, do you think? Maybe that's an unfair question.
I think it's a fair question. I don't think I have an answer, though. It's a very good question. I guess get Susie to organise more workshops. I think we need case studies. I sort of felt as I was writing this that I was just picking out particular examples here and there. You know, what if the intercurrent event's this, then we should do this. Trying to pull together an overall framework would be great. More software. But I think there's quite a lot to be done there.
Thanks. A question from Babak. Does the analysis take into account of the uncertainty in the weights when using the IPCW approach?
The answer is it should do. The surprising part of the answer is that the uncertainty in the weights, or the fact that the weights were estimated, once you allow for that, it actually makes standard errors a teensy bit smaller. Which is not what any statistician expects. And that makes it justifiable, I suppose, at some level, to ignore that uncertainty and be conservative. But yes, it should. And no, it's not very straightforward. You might need a bootstrap.
How concerning do you think it is, if you were to propose a strategy and state in the protocol and the SAP that you're going to use IPCW, and then when you come to do the analysis, you find that you end up in that scenario where there is no one that you can upweight because of no one with the same characteristics. And therefore the strategy can't be used, the analysis strategy can't be used. How concerning do you think that is? And how would you then handle it if it's what you pre-specified you would do?
I think that's a real problem. Because I think potentially there are situations where none of these techniques will work for a hypothetical estimand. So you could write that if IPCW fails, we will use a case or IV sort of method, because they make different assumptions. Their assumptions may not be valid, or the setup may be too complicated. So I suppose that would be a reason for being a bit cautious about using a hypothetical estimand. And I suppose you've got to be very careful about not specifying too many variables in your model if you're using IPCW. Yeah, it's a really good question.
You want to avoid perfect prediction, presumably.
You do, yes. And the standard statistician's approach of chucking lots of variables in because that's got to make things better might make things worse.
Question from Katie. Can we incorporate variability when ranking in the composite Estimand strategy?
Ranking in the composite Estimand strategy. So I think this might be referring to what Susie was talking about, where somebody who one of her intercurrent events in the methadone trial gets it handled by a composite strategy, assigned a particular numerical value. I think that must be what Katie's asking about.
Sorry, can I explain more?
Please.
Thank you very much for very useful presentation. So most of the strategies that has been suggested for composite Estimand strategy is that some type of ranking, either you think the worst scenario and use like the best and the worst one, or some type of like reference, or like using their baseline, for example. That's what my team wants to do it. But I suggested to use the baseline and incorporating variations. So variation from the people who have similar type of characteristics. But they said that because the definition of ranking is just like in the binary one, for example, which is composite outcome, is mostly comes from that, is like you either go for 0 or 1. So we have to have just the baseline. Nothing about the variation is going to be added to the whole process. But I feel like if we have, for example, in repeated measurement, if we have just baseline in there, we're going to end up having flat line for most of the people who have that specific intercurrent events, and it might cause some kind of convergence problem at the end, especially if we have many of them.
Can I have a go at answering that? I'm going to give you my opinion. I think other people on the panel may disagree. So I regard a composite as stating what your clinical value is for something. So this intercurrent event, you're saying, well, that is worth 0. So maybe on a quality of life scale or something like that. And viewed like that, there isn't really any place for uncertainty because it's not something you're estimating, it's a value. If what you're doing is you're wanting to assign a baseline value, then I think actually you're doing a hypothetical estimand and you're making the assumption that the value that we would have observed had the intercurrent event not happened would be the same as at baseline. And that's when uncertainty comes in the way that you're describing, Katie. So I think I think you're doing hypothetical, and I think you need to see it in that framework.
Okay, thank you. One final question, then we'll move into the exercise, if that's okay. So James has asked, how far do you think we should go in trying to incorporate this into our power calculations?
We often simplify things quite a lot, don't we, for power calculations? We often ignore things like covariate adjustment. How should we? I think that's a great question. I haven't even thought about it. James, have you got an answer?
Sorry. I was just wondering whether you thought, broadly, the similar approach, saying like we often ignore covariate adjustment in power calculations would be the way to handle it. Just as you were talking, I was suddenly imagining power calculations involving quite complicated simulation studies where you had to include the probability of various intercurrent events happening and incorporate a procedure for dealing with them, perhaps like you were talking about on, was it slide 27 or 26, and that made me a bit worried.
Yes, it's a good question. But I mean, we do know that, at least in some cases, treatment policy versus hypothetical could make quite a big difference to power.
Yeah.
So I guess we do need to think about it, don't we? Yeah. Sorry, I wish I had an answer.
No, that's okay.
No, I think one of the nice things about the workshop is, as you've alluded to with the principal stratification, sometimes issues is the areas for future research as well, and maybe how we incorporate this in sample size is an area that does need a little thought. Because one can imagine from a funding committee perspective, they're not going to appreciate several very detailed simulation-based power calculations in the 10 minutes they're discussing a HGA phase 3 trial, for example. Okay, I'm going to draw an end to this session.